Today we are going to discuss about a very important instrument used in the physics lab, the potentiometer. We are going to learn about its design, its principle of working, and thereby understand how it can be made useful for other purposes in the lab. To start off with, let us see what the potentiometer looks like. It is nothing but a straight wire, and you can choose any length of the wire. It could be 100 centimeters, 200 or more. You even have potentiometers measuring up to 10 meters of wire. Here is an example of a 400 centimeter wire which is placed on a wooden board with a scale attached to it. If you notice carefully, the winding goes from one end and the wire is looped at the other using a very thick conductor strip. That means this segment of the wire which is below this strip does not account for the wire length. So, this wire continuously goes in here, comes up, and likewise we have another section here which is a good conductor strip, and the length of the wire goes on placed like this. So, this is a 4-wire potentiometer. Each section of the wire is 100 centimeters. It has got two terminals, one at each end of the total length of the wire. Now, how does this work? Is there any requirement for the wire? Well, the most important thing is that this wire should be of uniform material. That means throughout it should have the same resistance per centimeter, which also means that you should have the same area of cross section. It should have the same homogeneous material. How do we then study the wire lengths from here? Using just one scale. I have a strip here which will help us see the scale on both sides. For example, if I have to read off what is the value of length here, all I need to do is to put this ruler along with it, and because I am starting from one end here, this length would be measured with the 0 side of the scale coinciding with the start of this wire. So, this will be my length of 45 centimeters. So, 45 centimeters is what I am reading here. On the second wire it would be 100 and additionally this length. So, I can read the second scale which is 55 corresponding to the 45. So, it would be 155 centimeters. So, that is how you read the length of the wire that you choose or select. Let us now understand its principle. If you put a potential difference, a constant potential difference across any length of wire, from our Ohm's law, we know that a constant current will flow through this, and determined by the potential difference across it, this current will be there. Now, what happens in the potentiometer is that the potential drop across any length of the wire is going to be proportional to the length that we are considering. That means that the potential drop per unit length of the wire should remain constant. Because the resistance per unit length of the wire is constant, this potential drop per unit length should also remain the same. This we are going to study in an activity just now. What we are going to do is use our potentiometer, connect a potential difference across it by using this battery eliminator, and suitable rheostat resistance so that we do not have too much of current in the circuit. We just have a key here to start the circuit. Over here we have a voltmeter which can measure the potential difference from one end of the wire to a chosen selected point on the wire. Remember, we will read the value of the length as we have just discussed. So, we are now ready to take readings of potential at different lengths of the wire. Let us look at the circuit. We have got the battery eliminator and a rheostat and a key, and this is the end of the wire. From the same point here, we connect the positive of the voltmeter and the other end is connected to a jockey. This is our jockey. What observations are we going to select? First and foremost, the range of this voltmeter, which is 0 to 5 volts. Least count of this voltmeter we have is 0.1 volt. The total length of the potentiometer wire that we have selected is 400 centimeters. We are now ready to take readings. We need to make an observation table which will record the length that we are selecting on the potentiometer wire. We need to record the potential difference that is there across that length of wire. Let us choose one end to be this terminal which we have marked positive on the wire. We switch on the current from the battery eliminator, put our plug key, and now across this wire we have put a certain potential difference. The current must be flowing through this wire. To select a length from one end, let us choose 50 centimeters, place our jockey at 50 centimeters, jockey which is connected to the voltmeter. This particular value here is the length 50 centimeter starting from the positive point to this one. Making a note from the voltmeter, this value is 0.5 volts. So, 50 centimeters is the length and 0.5 volts is the voltmeter reading. We can now take another length. Let us say I take the length on the next wire along the same line. So, 50 centimeters. This means we have got 100 centimeters from the first wire, and in addition we have 50 centimeters on the second wire, as you can see over here. So, 100 centimeters and of 50 centimeters to make it total of 150 centimeters. Let us take a look at the voltmeter reading. This value is 1.8 volts. Next reading, we step on to the third wire, and this time what will be the length? It will be 200 plus 50. Recording this value, the reading is 3 volts in our voltmeter. Let us move on to the fourth wire. This time our length will be 350 centimeters, 100 for each of these plus additionally 50. Let us see our voltmeter reading. This value is 4.3 volts. We can take any random position also. Let us select any length, any position here, and find out what will be this length, and corresponding to that find out the potential difference. 240 centimeters on this wire, and the potential difference here is 2.9 volts. We can now find out for each of these readings how much potential difference per unit length. If this value comes out to be a constant, that means the principle of potentiometer is correct, which is that the potential drop across any length of a wire which is carrying a constant current and which has a uniform area of cross section, homogeneous material, so resistance per centimeter is the same, is going to be always proportional to the length. So, potential difference and length is what we were checking out just now. We can turn this circuit off and use our readings to plot a graph. This graph should also tell us whether there is any link between the potential difference and the length. On the x axis, we can put length, and on the y axis, we can put the potential difference. So, this is a potential difference versus length graph. On the x axis, we have to put values from 50 to 350. So, we are accommodating the entire length of the wire on the x axis, and on the y axis our readings are ranging from 0.5 to 4.3. That means, the scale on the x axis is 2 centimeters are equivalent to 50 centimeters of length, and on the y axis 2 centimeters are equal to 0.5 volts. So, let us plot this. For 50 centimeters we have 0.5, this is our first plot. 150 centimeters you need 1.8. So, this is going to be somewhere around here. Then the next reading is with 250, and for this the value of potential that we got was 3. For a length of 350, we recorded a potential difference of 4.3, which would be somewhere here, and in between we took another length of 240, and we said this value was coming out to be 2.9. So, somewhere at this point is what we have. Joining these points by a line shows us this variation. So, within experimental error, this is a straight line. The line here has an equation y equal to mx, y is the potential difference, m and x is my length. So, m, the slope is giving me v upon L, which is potential difference per unit length. This indeed is our value k, which is also going to be our potentiometer constant. If we change the potential difference across the wire, the net potential difference, these values will change, but the potential drop per unit length will remain the same. If you decreased at the same time the potential difference across the wire, the same thing would happen. So, the potential difference per unit length is going to remain constant in any conductor wire, provided it has the same area of cross section, it is homogeneous, that means it is made up of the same material throughout, it has a constant resistance per centimeter, which means there is no change in the resistance of the wire with temperature. So, if you have these conditions satisfied and a steady current flows through that wire, then the potential difference across any length is proportional to the length of the wire. This is the principle of potentiometer, which is used in the lab for doing other activities.